tails, right? Z represents number of heads, right? N is no total number of trials. N minus Z represents number of tails. So number of heads is Z. N minus Z is number of tails. So you are adding value to A and B, so, well, it's never an issue, right? Never an issue. So when you copy this, it's going to give you what? The denominator is going to be beta, B, capital B, Z plus A, N minus Z plus B. Just copy the A and B parameters here. But the denominator is going to be theta to the Z plus A minus 1 times, 1 minus theta. N minus Z plus B minus 1, right? Is it okay? Is it okay? Any question with that? I'm just, writing down the beta distribution, right? Right? I'm not changing much from the beta distribution, right? And then, we know beta distribution is a distribution, right? It is a distribution, right? To be honest, beta distribution should have been written like this. It should have been written. I'm sorry. I'm sloppy. I'm being sloppy on the notation. It's a formula. It's a function over theta. So here, I should have written like theta. Given A and the B value like this, right? It is a distribution over theta, right? So, having said that, when I do integral over the beta distribution, no matter what parameters I'm giving to A and B, the result should be 1, 2, right? Right? I'm just doing exactly the integral. So the important thing is here, integral beta theta. Here is like Z plus A, N minus Z plus B. This one, d theta, should be 1. Right? It is a distribution, right? It is a distribution. Right? So when you plug in this thing to here, once again, this is a fixed term. This is a constant, right? Just like here, once A, B value are fixed, the denominator is fixed anyway, when your A and the B parameters are fixed, right? So, it's going to end up telling you that the integration of this part, is going to be the same as your denominator, but this integration is this one, right? So from that integration, it also tells you this thing is right? okay, in order to show you, okay, in order to show you the last step makes sense, you need to use the fact, okay, facts, okay. First, this posterior is a distribution over theta. And also, well, beta distribution is a beta distribution, it's a distribution over theta. Right? Once we have these two, well, it's obviously the dots are connected, and these two terms are the same. In other words, this is a beta distribution with the A and B, this one to be A, this one to be B. Okay? Any question here? N 减 Z 加 OK, I'm sorry. It should be yeah. Okay? Any question here? This derivation should be pretty straightforward, okay? It involves really nothing but like a very simple concept, okay? So once you acknowledge that, okay, it becomes very interesting. I mean, first you know that, okay, if the prior is is a beta distribution, and the likelihood is the binomial. Okay, you can analytically derive the posterior, which is also beta distribution. So this makes beta distribution conjugate prior for binomial likelihood. Okay? So here I'm just trying to explain like what we have already explained. So nothing much to talk about. Okay? But the interesting fact is what? Think about this. Okay, remember I told you, okay, we can sort of consider prior here. We can sort of consider the prior to be how many number of heads and how many number of tails. Okay, I mean, we can sort of consider our prior, like that, and to set up the beta distribution for our prior. Remember? Okay? And then, okay, now the data you obtained has a number of heads and n minus a number of tails, right? Right? The data you collected has a number of heads and n minus a number of tails. And then the posterior you obtained, indicate that it's just like you have z plus a total number of heads, and b plus n minus z number of tails. It's very consistent, right? Very consistent. I mean, if you say the prior, say, I only know, okay, they are two-sided, okay? The coin has two sides. I mean, so I said A and B to be 1. So that, sort of, indicating like you throw the coin twice and you get a head once and you get tail once, right? So A and B both to be 1. Okay? And then say you throw the coin, Now you throw the coin 10 times, and you get one head and nine tail. The result is what? Result is a beta distribution using A to be 2, which is 1 plus 1, B to be 1 plus 9. That's exactly what the prior plus what the data tells you, right? Right? So this is very interesting. Okay, this is very interesting. Not only you can observe that, I mean, you know, obviously the beta distribution is conjugate prior, but also, okay, it tells you that, okay, the A and the B in your beta distribution, in your beta prior, actually, you know, and also obviously the posterior, okay, beta distribution, okay, the A and B in your posterior distribution, okay, has meaning. They have meaning, right? They have meaning, and those meanings, right? Those meanings make sense. So here I'm giving you a because now we attend with posterior and distal, right? So we can actually, you know, we don't need to use the numerical method to show the distribution. We just say that. So assume, okay, assume initially, before you have zero trial, zero head, meaning you haven't started your experiment yet. You haven't started the experiment yet. Okay? So, if you obviously you can do 3 distributions here, right? Those 3 distributions represent 3 different priors. Okay? You can see the blue prior is the flat prior, indicating that we don't know anything about the step, right? So that's why we say it's a minimal distribution, right? And the orange one is like a prior that we are sort of sure that the coin is true, right? Sort of, not very sure, but it's kind of sure, quite sure, because the mode and the new looks like it is exactly 0.5, right? And the green one, okay, is is like skewed toward the situation that the coin is like 10 to flip to 10 to get the tail, right? Because like the highest point for green distribution is 10, the value is the omega is 0, meaning the chance of getting 10, okay, is low, right? Low. So, okay, with these 3 different priors, okay, if you do one throw, okay, you get 1 prior, and 3, you get only 1 test. Okay, with the above 3 different priors, this is the result of posterior. You can see that, okay, for the blue one, okay, it's not due to the test. Should decrease that the test is becoming easier. Okay, but it's becoming slightly easier, not so deep. Okay, and the green one, okay, is not so sure anymore. Okay, it's moving toward the right. Okay, and then the orange one, because it's slightly more complicated, and obviously much more complicated than the other two. anomaly of the prior, okay, the posterior, when you have a lot of data, the posterior will converge. Right? You can see when you have 150 prior and 48 out of them is test. Then you can see these three distributions sort of like merge together, right? Okay, that's nature. Why? Because prior is only the pre-knowledge before the experience. But as you collect more and more evidence from the experience, okay, your data should dominate the result, right? That's also nature. Okay, very intuitive and very easy. Okay? And also, it tells you that, okay, you can see